Today's lesson is on factoring polynomials using division. And the idea here is just like in elementary school, when we're looking for factors, we can use division to find more factors. Our compelling question for today is essentially, how would we go about factoring a polynomial such as this one? The other day we learned about grouping and we learned about factoring things that are quadratic-like. With 5 terms, there's no way we can factor this using traditional methods. So we would say that is not factorable using known methods. So what we need to do is we need to find another way. Turns out that long division is a method that can get us there. Now, you're not going to be tested on long division, but it's important to know the context of where this comes from. If we kind of go back to elementary school and we take a look at what might happen if we try to see how many times 11 goes into 57,386. Through this process should be familiar. I'll walk you through it really briefly. But the idea here is we go digit by digit to see how many times 11 might go into those digits. So 11 won't go into 5, so we have to go over to the 57. We know that 11 goes into 57 about 5 times. We multiply 5 times 11 to get the 55. We subtract to see how much remains. We bring down the next digit. And now we look to see how many times 11 goes into 23. Well, 11 goes in twice, and there's going to be some left over here, but we'll go ahead and multiply 2 by 11 to get 22, and subtract to get 1. Bring down the next digit for the 18, and then we ask the question again, how many times does 11 go into 18? That answer is 1. 1 times 11 is 11, and we subtract. Bring down the next digit. 11 goes into 76, can't be 7 times, it's going to be 6, and we subtract to get a remainder of 10. So what that tells us is 57,386 is not divisible by 11. If the remainder had been 0, then that would be a factor. What we're about to do then is go into what would that look like if we had polynomials. So the question we might ask is, x minus 2 is a potential factor of this thing. So we'll go ahead and use long division. We'll put the polynomial underneath the division symbol. So I got 2x to the 4th, 3x cubed, 5x squared, 3x, 6. And I want to know if it's divisible by x minus 2. What we will do now is we will look at these 2 at a time, because I want to know how many times x minus 2 goes into certain portions of this. We will look at these 2 at a time. So if x minus 2 goes into or is a factor of 2x squared minus, that is 2x to the 4th minus 3x cubed, I'm going to divide the lead term by the lead term. 2x to the 4th divided by x is 2x cubed. I put that on the top as a part of my quotient. Then I multiply by the outside and I put it underneath my 2 terms. So 2x cubed times x is 2x to the 4th, and 2x cubed times negative 2 is negative 4x cubed. I am now, just like I did in my previous long division, going to subtract. 2x to the 4th minus 2x to the 4th is 0x to the 4th. 3x cubed minus negative 4x cubed is going to give us a value of positive 1x cubed. It's negative 3 minus 4x cubed. That ends up being positive 1. We will bring down the next value, and we will repeat the process. I'm going to take 1x cubed, and I'm going to divide it by x. That gives me 1x squared. I will then multiply by the outside. I get 1x cubed minus 2x squared, and I will subtract. These 2 subtract to 0. Negative 5 minus negative 2 is negative 3. I will then bring down the next term, 3x. I will look at my lead, Negative 3x squared divided by x is negative 3x. I will then multiply by the x minus 2. Negative 3x squared plus 6x, and I will subtract. Those are gone. I end up with negative 3x. Bring down the final term of plus 6, and we divide one more time. Negative 3x, x. If we divide those two, I get a negative 3. Multiply by the x minus 2 gives me negative 3x plus 6. We're in quite good shape here now, because if I subtract, I get a remainder of 0. So the answer to the question is yes. We could write our original polynomial as x minus 2 times the result of the quotient, which is 2x cubed plus x squared minus 3x minus 3. If we were asked to now, we would have a chance to factor this further. One more quick example here of long division. We're going to go ahead and divide this cubic polynomial by x minus 2. I'll look at my lead terms. 6x cubed, divided by x is 6x squared, and then I distribute to the x minus 2. 6x cubed minus 12x squared. Subtract. And I get the lead terms to go. Negative 19 minus negative 12 is negative 7. And I bring down the 16x. And then I divide again. Negative 7x squared divided by x is negative 7x. And then I multiply. Negative 7x squared plus 14x. Put it in parentheses and subtract. 16 minus 14 is 2x. The lead terms subtract off. Bring down the final term of minus 4. Divide once again. 2x divided by x is 2. If I distribute, I get 2x minus 4. Subtracting gives me a remainder of 0. So if we were then asked to completely factor the polynomial, we could rewrite 6x cubed minus 19x squared plus 16x minus 4 as x minus 2 times 6x squared minus 7x plus 2. We now have a quadratic that we can put into factored form. This factors with a 3x and a 2x, a 2 and a 1. Minus 2, minus 1, and we have a polynomial in factored form that we could not have otherwise done using traditional factoring methods. Next, we are actually going to look in a more efficient way. That process is a little bit tedious, a little bit cumbersome, but there is a process that I'm going to show you really briefly here called synthetic division. And synthetic division is kind of a trick that allows us to use just the coefficients and a little bit of multiplication and addition to determine whether or not something is a factor. And we're going to go ahead and show you the setup here right now. This is the setup of a synthetic division problem. This number right out here is a 0, and these numbers across what I call inside the box are coefficients. Coefs for short. And this synthetic division problem actually is the answer to the question, is x plus 3 a factor of 1x to the 4th plus 0x cubed minus 10x squared minus 2x plus 4. Each coefficient is used and has a placeholder in the polynomial. We are going to use a process of adding and multiplying. You're going to use addition to get out of the box, and you're going to use multiplication to get back in. What I mean by that is you're going to add vertically using the first coefficient to get out of the box and get a 1. You're then going to multiply what's outside the box by the term in front to get a -3 to get back into the box. You're going to add 0 and -3 to get out of the box. You're going to multiply -3 by -3 to get back in. Add to get out, -1. Multiply to get back in. -1 times -3 is 3. Add to get out, 1. Multiply to get back in. -3. 4 plus -3 is +1. In synthetic division, this final entry represents the remainder. So in this case, since we have a remainder of 1, the answer to the question is no. And what would we do at this point? We would have to find another potential factor and do some division again. Synthetic division is kind of a trick, but I'll go through a couple more examples just to kind of give you a feel for it. X minus 3, a factor of 2x squared minus x minus 15. I'm going to lay my coefficients in order across the top inside the box. I'm going to put +3 on the outside because 3 is the value that makes that factor 0. We'll go ahead and add to get out of the box, multiply to get back in. Add to get out of the box, multiply to get back in. Add, and you'll see now that we have a remainder of 0, so the answer to the question is yes. If we were to back up just a few moments and we were to take a look at 2x squared minus x minus 15 as a parabola, if we were to factor out an x minus 3, 2x plus 5 would be the other factor. Worth noting that 2 is here and 5 is here, which shows us that the result at the bottom of the synthetic division is the other factor. Let's take a look at a couple more. Is x equals -8 a solution? Since we have the 0 value, we're going to go ahead and put that outside. We don't have the factor. We want to know if this number is a solution to this equation. 2, 10, -46. Add the first coefficient down, multiply to get back in the box. Add to get out, multiply to get back in. Add to get out, and this last entry will always be your remainder. What do we do now? Nothing. The answer is no, so we cannot factor this polynomial any further. Here's example 4. Take a quick peek here. If I make my synthetic division box, -2 is here because we're looking at the 0. We're not looking at the factor. 3, 4, -3, 1, -2. Start with your first coefficient inside, add to get out of the box, multiply to get back in. Add to get out of the box, multiply to get back in. Add to get out of the box, multiply to get back in. Add, multiply, add. We have a remainder of 0, so the answer is yes. The factored form we could now write is x plus 2, which came from the 0. Our resulting coefficients, I often will write them in backwards order. -1 is the constant, +1 is the x coefficient, minus 2x squared is the squared term, and 3x cubed is the lead term. Those things go in increasing order from right to left, and this would be the factored form. If we were asked to, we could go further. This one, I'm just going to take a quick peek, and it looks like grouping's not going to work. We can talk more about that in another time. Let's go through one more example. Actually, let's do 2. I highlight these examples because we have a missing term in our polynomial. So we'll go ahead and write out our coefficients very carefully. Here's our box. X to the 5th has a 1. The missing term is x to the 4th here. So I'm going to put a 0 in place of the x to the 4th. If I don't, I'm going to miss out on the correct quotient here. X cubed, x squared, x to the 1st, and the constant term at the end. I want to know if x equals 3 is a 0, so I will put 3 out here, meaning x minus 3 is the potential factor. Have to use the 0 as a placeholder. Add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and we get a 0. So the factored form then would be x minus 3, and this would be, I divided an x to the 5th by an x to the 1st, so I would have 1x to the 4th, 3x cubed, negative 2x squared, negative 1x, and 5 would be the factored form. This polynomial now, we would potentially have to do another division in order to factor it further. We'll save that for another day. Last one. Is x minus 2 a factor of x cubed minus 8? My coefficients are 1x cubed, 0x squared, 0x, minus 8. X minus 2 a factor, we're going to put a positive 2 outside. Bring the first coefficient down. Multiply, add, multiply, add, multiply, add. X minus 2 is a factor of x cubed minus 8, and the factored form, x minus 2, x squared plus 2x plus 4 is what remains. The idea behind this method, and again, synthetic division is a little bit of a trick, but the idea behind this method is to take polynomials and put them into factored form. Over the next couple of days, we'll talk about how do we know what to divide by if it doesn't tell you. If I just give you the polynomial, what are some strategies we can use to determine what's a good idea for division?